Hello learners, welcome to Education Online program, and with you is teacher Willa Lucia. We shall be covering physics, but in particular atmospheric pressure. Atmospheric pressure. In our previous lessons, we've been talking about pressure in solid, then there is pressure in fluid, what factors affect pressure in fluid, and even pressure in solid. We talked about the applications of Pascal's principle, where we talked about the machines, the hydraulic machines. So today we shall be seeing atmospheric pressure. So what is this atmospheric pressure? If you're to check, it comes from two words. We have the first word here as the atmospheric. Then we have a second word, that is pressure. Our atmospheric comes from a word known as the atmosphere. So what is this atmosphere? If you're to define atmosphere, we say that atmosphere is just the air surrounding the earth. So if it is the air surrounding the earth, what if you combine it as atmospheric pressure? How will you define it? You'll find out that to define that, you'll have it as atmospheric pressure. Atmospheric pressure is the pressure caused by weight of air on all objects on the Earth's surface. Now from our definition, you'll find out that if atmospheric pressure is the pressure caused by the weight of air on all objects, it means that each and everything that is on the earth, as long as it's on the Earth's surface, it does experience what is known as the atmospheric pressure. But why is it that we experience it but we don't feel the effect of atmospheric pressure? We do not feel the effect of atmospheric pressure because atmospheric pressure at, let me say, altitude, the value is 1.0 times 10 power 5 pascals. If that is the value, you see that the value is really big, but we do not feel it. There are two reasons as to why we don't feel this atmospheric pressure. One is because we say that pressure is transmitted equally. So this atmospheric pressure here, atmospheric pressure is felt equally in all directions. That means that if I am here, it doesn't mean that the atmospheric pressure acting on this shoulder of mine here is less than this. Because if it is like that, I'll be like bending this way. I am straight because every point on my body is receiving the same amount of pressure from the surrounding air. That is the reason as to why we do not feel the atmospheric pressure. And also our blood pressure. The blood pressure in animals is much greater, or slightly greater than the 1.0 exponent 10 pascals. That is another reason as to why we do not feel this atmospheric pressure. So you find out that atmospheric pressure depends on altitude. Why? Why do we say that it depends on altitude? Okay, if we're talking about altitude, what is this altitude first of all? We are saying atmospheric pressure depends on altitude. So you can define this altitude. This altitude is just the height. We can say it's the height measured from the sea level. From the sea level. And since it depends on altitude, you see that the Earth's surface is not just flat. If it was to be totally flat, yeah, we shall say everywhere we receive the same amount of atmospheric pressure. But then we have the highlands, things like the mountains, we talk about the hills. So these ones, the pressure there is a bit different. If we talk about, there's also low lands. We talk about the valleys, we have the rivers, and we have the seas. So the pressure also there is different. So we still also have, there are also some lands that are a bit flat. Yeah, so that part of the land also receives different amount. You see, when you're going high, this altitude here, as you're going higher the altitude, the atmospheric pressure there reduces. That means that pressure reduces with increase in altitude. This explains why when you're on a higher ground, you find out if you're cooking something or boiling something on a higher ground, the thing fails to boil faster. This is because there is reduction in the pressure that is received high there than a person who is boiling something at a flatter area or lower area. So the more you go, the lower you go, you find there will be increasing pressure. But the higher you go, the pressure keeps on reducing. So if that is the case with atmospheric pressure, how shall we know that there is atmospheric pressure actually acting on the Earth's surface? Let's look at this experiment here. Okay. In our experiment, we are going to have a can. I'm just going to illustrate it on the chalkboard, but if you have time, you can also try it out practically, so that you see the effect of atmospheric pressure. So we shall have a can. We need source of heat. Then we need, we can have a stopper, or you can call it a cork. We need some water. We need cold water, and then hot water. So what do we need these things for? We need them to demonstrate effect of atmospheric pressure. What you'll do is you get these things if you have the can. If you don't have a can, you can use any other thing like a plastic bottle. So when you get your can, let's assume this is our can, something like this. When this can is empty, and open like that, what happens is that there is atmospheric pressure acting on the surface of this can, and it is equal throughout in all direction. It is acting equally. So now get this can, we are going to fill it with some water. So we have our can there. If we fill it with water and then heat up the can, this is our source of heat right there. So what happens when this water is boiling? Remember, still the atmospheric pressure here acts on all the surface of the can equally. So that's why it is still the same the way it was here. So as you're heating up this can, what happens is that this water keeps on warming and then starts boiling. When it is boiling, there will be steam. There is production of steam. It will be releasing steam. This steam here drives all the air that was initially in your can. So as it is driving this air, the liquid, the water you're left with in the can is going to be totally without air. It will be just water, because all the air here has been driven out in form of the steam. So if it happens like that, now you remove the source of heat. We are going to eliminate the, okay, we need to eliminate this source of heat and see what happens. Eliminate this heat and you still have your hot water here. This is already hot water. Now this one is where the cork comes in. You get your stopper and close it. You close it so that the steam does not condense back to form oxygen there. So we remove all the air. Now we close the hot water in the bottle. After you closing it, get some cold water and pour in this. Just pour on the surface of your can. If you pour water, what will happen? You will see a change in the shape of your can. What kind of change? This is how your bottle will crash in. When you pour the cold water on it, we assume this is our cold water. So this is our can. The shape of this can will change into something else, like this. Now, why did it change? From here, you had an empty bottle, an empty can. You poured water, the can was still okay. You started heating the can, there is nothing happening to the can. You came here, you removed the source of heat and closed the can. So after closing it, you poured cold water. When you poured cold water, you saw that the can changed. The shape of the can was totally changed. What happened is that when you were boiling, we say that you removed all the air inside the can, and yet it was this air inside this can that is balancing out the atmospheric pressure that is acting on the surface. So since you already eliminate this air, inside here we no longer have any air left to balance the atmospheric effect of atmospheric pressure that is on the bottle. That's why when you poured cold water, this atmospheric pressure here is going to be greater than the pressure inside the can. That's why you find out that your can crashes inside. And this experiment is known as the You can call it as the crushing can. It is known as the crushing can experiment. So when someone tells you to demonstrate or explain the effect of atmospheric pressure by the crushing can method, you know that this is what you're supposed to do. You can also try, I said, when you don't have this can, you can do it locally at home. You just get a plastic bottle. When you get your plastic bottle, of course you cannot heat a plastic bottle, it will melt. So what you do is first get your water and heat it up. First boil it using a saucepan. Then after that, you get your bottle, try to pour that water. You can use a funnel so that you don't get burnt, and transfer it into the bottle. So as you're transferring it into the bottle, remember it is already hot water. Even before you closing the top of your bottle, what happens is that the bottle will immediately start crushing. This is because as you're pouring the liquid, the hot liquid in your can here, it is driving away immediately. It keeps on driving the air inside there, so reducing the pressure that is inside the bottle. So when this pressure inside the bottle is reduced, the atmospheric pressure becomes greater than the pressure inside the bottle. That's why you find out that your bottle will automatically crash. And make sure your water is really boiled. If you don't want it too hot, there is no problem. When it boils, you can then close and try to throw the bottle in cold water. At least you will see some little effect of the atmospheric pressure. If you don't see it, you can still hear the cracking sound. If your water isn't that hot, you will hear just some cracking sound. So it is deforming the bottle in a way that you're not seeing, but it is there. You can try that out. So this atmospheric pressure here has got several applications. What are these applications of atmospheric pressure? We can have it here as application. Applications of atmospheric pressure. So atmospheric pressure is applied in very many things. For instance, we have what is known as the lift pump. There is some effect of the atmospheric pressure that acts on the lift pump so that it can actually function. We shall see how it works. Then we also have what is known as the force pump, which also uses atmospheric pressure. We have the drinking straw. The drinking straw. We shall see how the drinking straw, how atmospheric pressure is applied when you're using the drinking straw. We have very many of these. So a few, if we are to list a few, this is what we have. And then we shall be looking at all these applications one by one. We can start with the lift pump as we go on. So how does it affect the lift pump? Let us see how we apply atmospheric pressure on the lift pump. And what is the example of the lift pump? We shall be talking about the lift pump, yet we might be thinking we have never seen one, yet we have ever seen. So a lift pump, an example can be a borehole. I think that one is widely known. At least that one most people know what a borehole is. So if you're talking of a lift pump, this is our okay. The lift pump. How do we apply the effect of atmospheric pressure in the lift pump? So you'll find out that this lift pump here is mostly used to drill water or to remove water from very deep well. So this lift pump, it has, let us have a very simple diagram of that so that we can explain with it how it works. So the lift pump has what is known as the spout here. So we have this cylindrical thing which is known as the barrel. So it is connected, it comes down inside the lift pump. Let's make it look much better. We have the barrel here. The barrel has the spout. So when you go down, we shall have a valve here. Okay. This one is holding a valve. We can call this valve A. Let's write in full. This is A. Then we go down. It is connected to a cylindrical pipe down the earth. So we also have another valve here. So this is valve B. We also have a piston here, or you can call it a plugger. So this goes like that. Okay, we can have it like that. It's just a very simple diagram so that we don't explain while not seeing where the valve is supposed to be and which one is the barrel. Okay, something very simple like that. Then we have the liquid here. This goes underground. So we want to remove water from underground out. So this has some liquid in it. We can have it like that. So how does this work? This works in two ways. There is what we call as this is its barrel. There is what is known as the upstroke and what is known as the downstroke. Because it is the upstroke and the downstroke, that system that helps us to have water coming out of the spout. Then how does this upstroke or downstroke work? Let's see this. We shall start with the upstroke. Let's write it as the working of a lift pump. We are going to start with the upstroke. So what happens? For you to know the working of this, it is just the working comes out from the piston. When the piston is moving up and down. So this we can put it as our piston. Its up and downward movement brings about this. During the upstroke, what happens? During the upstroke, you find out that this valve here opens. We are going to use the same diagram for upstroke and also for the downstroke. This valve B will open, and then valve A closes. Why does it close? This is because there is a gravitational force that is acting on our valve A. So this gravitational force pulls it to close. Not only the gravitational force, but also there is pressure from the weight of liquid above it. So this pressure here forces this valve here to close. And then when it closes, what happens is that there is atmospheric pressure that is acting on the surface of the liquid. So when atmospheric pressure starts acting here, what happens is that it is going to force this liquid through this cylinder or the pipe up through the valve B into this space here. So every time you open this, atmospheric pressure that is acting on the liquid will force this water to go up the barrel. So when it goes up the barrel, remember this one is already closed. It does not cross to the other side. So the liquid that is here, during the upstroke, we are pulling the piston upwards like that. So since this one is closed, you're going to see that as you're pushing your piston up, the liquid here is going to be forced out through the spout. Then when it is forced out, that means there will be a need for you to push this piston back inside. So as it is coming back downwards, that is what is now known as the downstroke. It is the downstroke. So when it is now moving down, it becomes the opposite. Instead of this one closing, instead of this one opening, it is going to now be this one to open, because as you're pushing this down, you're adding weight on the smaller, on the valve B. So when you're adding weight on this, there will be also the gravitational force acting on it, forcing it to close. So during downstroke, you find out that the valve B here is going to close, and then the valve A here will open. So our valve A here is going to remain open. So if this one now closes and this one opens, that means that it is now the downstroke action working. So it means we are now bringing our valve a bit down. So when you come with it down, that means that this water here, when you close, the water that was already taken up by the effect of atmospheric pressure through the pipe and the valve B that was in the barrel here will move. It will be pushed through this valve A, because it is now open to the open space to the barrel here. So when it is moved here, that means that we are also going to go back to the action of the upstroke. So it keeps on changing. After this upstroke, immediately it is downstroke to fill the barrel. So when you fill the cylinder, when you fill the cylinder here, that means when you're going to pull this down, this one is going to move up. As it is moving up, it goes back to the action there, upstroke, goes back to upstroke. So it keeps on like that. That's when you see that when you're pumping water, as you keep on pumping, water continuously comes, because as you take the handle down, you're pulling your piston from inside the barrel up. So as you're taking that handle up, the piston goes down. So I hope we have now seen how upstroke works, and then the downstroke in a lift pump. So what we have to know is that atmospheric pressure is that pressure that is acting on on every object on the surface of the earth. So you should be in position to define atmospheric pressure. You also know that you should be knowing that atmospheric pressure depends on the altitude of the place. Okay, so with this we come to the end of our lesson, but as we said, there are very many applications and we are going to look at them one by one. So in the next lesson we shall still go ahead and continue with the applications of this atmospheric pressure. Thank you very much for joining me in the program. We shall meet again.